Hey guys, this is Mr. Quinones giving you a tutorial or review on what you need to know for your next chapter test 7, 11, and 17. So let's get right to it. Number one, you need to know the properties of certain geometric shapes. Okay, so you need to know the properties of shapes. One of them you need to know is that this is a quadrilateral. Okay, so I'm not sure if I'm going to be able to write all the stuff, but whoops, that's a Q. Quadrilateral, anything with 4 sides, and you need to know that if you have a quadrilateral with 2 parallel sides, that doesn't have 90 degrees. And this one is called a parallelogram. Okay, you guys can find out how to spell these things properly. I'm just going to kind of go through through everything quickly. This one is a kite. Okay, and then you have a rhombus. It's like a diamond. You have a square. You have a rectangle. And of course you have your triangles. But this is the quadrilateral. Square, rectangle. And there's also a this bad boy, trapezoid. Alright, so just take notes here and then go look at them and make cards and study the cards. So you got to know all these properties and what they are. Real basic stuff. Okay, for example, as an example, the parallelogram, the angles are not right angles. Okay, so the difference between these two is that these are all right angles. They do have parallel sides. These are parallel, and these are 90 degree. But a parallelogram is sort of like a weird looking rectangle. Kite is kind of like a rhombus, except that the bottom part right here is longer. This one has all equal. And you gotta know something about the diagonals. Man, my pictures are horrible. I am so sorry. Okay. So you want to know that for example, this one right here, the diagonals bisect each other, 90 degrees, equal sides. These diagonals, I think bisect each other. I'm not sure. I gotta look that up. These do bisect each other, but these do not. Only one bisects the other. So that's the idea about the shapes, properties of shapes. You will not be able to use your index cards because otherwise it means that you are just using your index cards. I want to see what you can hold in your mind. Alright, next. See if I can write a little nicer for the next one. Alright, next. You really want to understand the properties of a kite. Okay? And you want to understand the diagonals, that a lot of the diagonals, these are equal, but these are not, and these are 90 degrees. So you could use trig, and we've practiced a lot in class. You guys taught each other, you practice and practice how to figure out all the missing lanes of any kite if you know an angle or 2 sides or something like that. So look at all your notes. For example, this one, you want to know, you can pretty much pick anything here. If I knew this was 10 and this was 30 degrees, then you should be able to figure out everything. So for this one, for example, this is 30, this is 90, that's 60. So 30, 60, 90. I think I need one more. I need one more measurement. Yeah, I think I need another measurement because this the oops. I don't know how to undo. Oh well. This the one opposite 30 degrees is half of this, but we don't know this or that. So I need one more measurement. Just give you one more. Let's just say this is 3. Okay, let me just use green for. So if this is 30, what the heck? All right, so this is 30, and this is 3. Therefore, this is 6 because this is half of the hypotenuse, so or the sine of 30 is 0.5. So this will give you 6, and then from here you could figure out this piece of it by using the cosine of 30 is the missing divided by 6, which is the one that was here. So just a little review of that. And then once you have all these pieces, you can do the area of this triangle right here, which would be base times height divided by 2 times 2, or just base times height. Then you go to this side right here, since you know the what do you call it? The hypotenuse and one of the legs, they can use Pythagorean theorem. So c squared minus a squared will give you b squared. Or you can just type in the calculator like this. We'll call this b. B equals the square root of 10 squared minus 3 squared. And notice I put minus because we know the hypotenuse. So you subtract the hypotenuse from one of those. So you really want to know the kites really well. Okay, so study those. Perhaps make 1 or 2 practices and do those. All right, next. All right, next you want to really be able to use the coordinate plane and be able to use the distance formula to measure different shapes. So, for example, let me see if I can bring in a grid. I think I can bring in a grid in here. Not 100% sure. I was testing this out a while ago. I could have sworn I saw a grid. I'm going to put an equation. Y equals 0. Let's see if it graphs it. Yay! Whoop whoop. All right, so I tricked this into bringing me a grid. I put y equals 0 so I wouldn't really draw anything. So anyhow, so you're going to be giving some points. For example, I don't know. I'm going to pick. Just give me some points. 3, 2. 3, 2 will be here. And then some other point, like -1, -2. And then some other point, over here somewhere. Or maybe 4 points. So anyway, so you're going to be giving some points, and let's say I gave you 4, and then here's 2, and then here's some other one here, and some other one here, and you'd have to tell me what kind of shape it makes and prove it. So for example, if it was a rectangle, right? If it was a rectangle, these would have to be 90 degrees. right here. So it had to be from here to here, those points. And then these would have to be the same distance if it was here to here. So I'm not going to do the whole thing because I want you to just kind of practice drawing some and figure out the distance from these two. So the question is, what is the distance from here to here? And I've been teaching you guys that the distance equals the square root of how far these are, the x's. So these are 4 apart, which is your A. Okay. And then how far the y's are apart, which is also 4. Okay. For that one. Anyway, so this distance equals 16 plus 16, the square root of 32. And then your calculator will give you some answer. You can also simplify this by saying this is actually the same as this. Okay, you agree with that? And you could say this ultimately becomes 4 times the square root of 2. So this will give you the same as this one, the same as that. They're all the same. So for this part of your exam is you need to know how to find distance with coordinate points and what shape they make based on those distances, whether it might be a rectangle or a square or a kite or all that stuff, kind of connecting everything together. Alright, next. Alright, the next thing that we kind of been working on is how to use the slope. I'm sorry, let's go back real quick. Alright, how to use the slope to figure out if lines make a 90 degree. So again, let's see if I can bring in another graph again. You see, should have saved it, huh? I think I had typed y equals 0. Wonder if I can just make it to a graph. No. See, I have to trick it into making me a graph. So I'll put y equals 0, y equals 0, and graph. Okay, just get rid of that. Bye-bye. Okay, so the idea here is if you had some shape, okay, let's see this one, and then over here, alright, so let me see, I want to make sure I'm doing this right. So this one is up to 1, 2, 3 over 3. So I want this one to be down 3 over 2. There we go. I think that this one should also be down 1, 2, 3 over 2. Went too far. It's going to be this one right there. See if I can erase this. Alright, so anyway, cross that one up. So here's some shape. And you need to know how do you know if it's 90 degrees or not? Okay. So what you can do is you can figure out the slope. The slope of this one is up 2 over 3. So you can write m equals m for slope. I don't know why it's m, probably for mountain. This slope is up 2 over 3. And then versus this slope, 1, 2, 3, whoops, 4, 1, 2. So I went too far. In order for this to be perpendicular, it would have to be the opposite reciprocal of that. So it'd be down 3 over 2. It'd have to be right here. Okay? And that would have been perpendicular. So perpendicular slopes. Okay, you can write that down in nice, neat notes. Perpendicular lines. Okay, perpendicular lines have opposite and reciprocal slopes. Okay, sorry about my notes. Slopes. For example, 2 over 3 versus negative 3 over 2. And this is how you can prove that that this is 90 degrees. Right here. Alright, so you need to know that. So you should make yourself a flashcard for this. Okay. Okay, so you got all the properties of rectangles, kites, and parallelograms. You got to know those. Okay. Okay, next, you need to know how to find the area and volume of a cone. Okay, so you got your cone, and for the cone you need your radius, and you also need your height. Okay. The formula is volume equals pi r squared times height divided by 3. That's the way I like to do it. Or some people like to do it like this: 1/3 of pi r squared times height divided by 3. Or I actually like to do it like this. I like to get r squared times h times pi, and I like to divide the whole thing by 3. Personally, that's how I like to do it. I like to get the numbers, because typically these will be numbers right here, and then the numbers times pi, and then you get that answer and divide it by 3. So it doesn't matter when you multiply; these are all being multiplied. Which order they are in, as long as you divide the whole thing by 3, or you can divide one of them by 3, and that'll make the whole thing 1/3 of it anyway. So you also need to know how to get radius from circumference. Okay. So what I want you to do, let me see if I can move this around a little bit. So say if the circumference is 20, then radius equals how much? So you want to remember that this formula for circumference is, the circumference is the diameter times pi, which is about 3 diameters will give you a circumference, or the circumference is 2 radiuses times pi. So therefore you know 20, so you can plug in 20 right here. You put 20 equals 2r times pi, and then you can divide this by 2 pi, and that cancels that out, and divide it by this, and this can divide, and that becomes 10. So 10 divided by pi will be your radius for this one. So basically, you cut this in half, and then you divide that by pi. That gives you your radius. Because you're going to need this for your cylinder, and maybe we'll have to give you questions where we don't really give you R, but we give you something that you can get R from. Okay. Alright, and then also you have to know how to get the volume of a sphere. Okay. Oh, look, I can draw shapes. Yay. Did not know that. So here's a flat circle, But I'm going to make it three-dimensional now. Look at this. Look at that, cool. Now it's 3D. So the volume of a sphere is 4/3 pi r cubed. Pretty simple. Okay. I'm going to be asking you to do a couple of manipulations for this one. I'm going to say, for example, if you had some clay and you made a sphere with a radius of, I don't know, for example, a radius of 6, then, oh look, my son just landed, yay. So then you can figure out the volume of this sphere by plugging in 6 here and doing all kinds of work. Let your calculator do the work. And then I asked you, with the same clay, can you also make a cylinder? Okay. And the cylinder will be oval here. Oval there. And then I'll ask you, what is the height of it if you made it the same radius or something like that, you know, the same r, which would be 6. Then you'd have to figure out what the height is. And then I might ask you, well, you got bored of that and then you wanted to make a cone with the same volume, the same material of clay. And what would be your height of your cone if you use the same radius or something like that? What would be your height? So that your cone will look something like, I don't know, let me see. Well, excuse me, guys, I'm learning this cool app that I paid money for just for you, because this is what I do for my students. Alright, so then you have to make a cone with the same radius. Right, I wouldn't say it's 6 for my example. And so basically, you're going to have to undo some formulas. So the volume of a cone is 1/3 pi r squared times height. So if you started here and you found your volume of your sphere, then you'd have to insert that volume into here, into your volume of your cylinder, which this volume is pi r squared times height. So basically, let's pretend, all right? Just let's pretend. Let's pretend that you put in 6 here and you got some number. I don't have no idea what it is because I don't have a calculator right now. But let's pretend it was 300. I have no idea. But 300 cubic units. So then now you know it's 300. So now you can put 300 right here. This will be 300. Okay. And then you can put a 6 here. If I said the rate is going to be 6. And then you're basically going to put 300 divided by pi times 6 squared. So you divide 300 by that, and that'll give you your height. And then you put the same 300 over here, because it's still the same volume, and you do the same thing. But in this one, it says 1/3. So then you have to multiply the 300 by 1/3, which will give you 900. That's how you're going to get rid of 1/3. And then you're going to divide the 900 by pi r squared, and then r will be 6 squared, so it'll be 6 times pi, and that'll give you your height. Alright, so basically I'm going to ask you I basically want to see how well you can do algebra and how well you can understand how one shape relates to another. Okay guys, so this is the best I can do right now. Make some study notes on this as extra credit and post it. I'll make a new thing, maybe it's 51 on the Google Plus, but totally make really nice notes that other people could be like, whoa, that guy is so cool. I want to be just like that guy. Or girl. Probably girl. Alright, thank you. Good luck.